Welcome to my Cisco's Routing and Switching Essentials. In this lab, we're looking at lab 8412, which happens to be the Skills Integration Challenge. Normally, I don't do these, but I've actually had several students ask me to help them with doing them. So I'm going to go ahead and I'm going to do a few of them just to show that they're out there. So we have our diagram, we have our instructions, we have our individual requirements. So I got a notepad open just so that I can have everything ready. So let's go ahead and IP addresses according to the address table. We're going to set up the appropriate process ID. We're going to set up the appropriate router ID. We're going to go ahead and set up the appropriate network addresses. And we're going to go ahead and set the interfaces to passive. So for router 1, I will do router OSPF. We're setting it to ID 1. We are doing a router ID of 1.1.1.1. We want to do a passive interface. And we're going to do that off of gig 00. We're doing RA. We're doing that as the passive interface. Next, we have two network statements. Network 172.31.0.0. We also have network 172.31.4.1. Sorry, 4.0. These are network statements, not IPs. So look at the subnet masks and make sure to do the appropriate wildcard. So here, 255.255.254.0, that should be the inverse of that. Next will be the inverse of a /30. All right. And last thing we have to do is we have to tell it area 0, because both of them are belonging to area 0. Even though it doesn't say what area, we're just going to assume area 0 because it requires area 0. So RA with those instructions are now complete. Okay, moving on to these steps. On our router 2, first thing we have to do is set up IPv6 unicast routing because we're doing IPv6 here. Next, we need to make sure that our interface gig 0, it specifically said on gigabit 00 to the link local address as FE80::1. So how we do that is IPv6 address FE80::1 link local. And sometimes Packet Tracer likes this, sometimes it doesn't, so if it doesn't work, it's okay. Moving on, we're doing router OSPF version 2. So router OSPF, we're calling this ID 1, router -ID 2.2.2.2. We're doing network statements and we're doing a passive interface. So again, we're looking at these networks right here. And we're just doing the IPv4 addresses. It's just those guys right there. It'll be network 172.31.2.0, network 172.31.4.0. Next, look at their subnet masks and do the appropriate wildcards. Here we're doing, remember, wildcard just means inverse. Okay, so that's the inverse of that subnet. The inverse of the next one should be .3. And make sure that you're doing area 0. We're still doing single area OSPF right now. And so we've done that, we've done that, we've done that, we've done that. Let's set the passive interface to gig 0. So passive-interface gig 00. So we've done that part. Now let's go on and let's make sure that we do the remaining portion for OSPF version 3. Enable IPv6 routing. That's the first thing that we did. Let's go ahead and set up the process ID for that. IPv6 OSPF1. Got to make sure that we're telling it that we're doing routing. So router OSPF1. These are going to be very similar, except you'll notice here we're telling it specifically IPv6. So there we go with that. Router -ID. Even though we have already declared it up here, we're going to have to declare it underneath this instance of OSPF because they are different instances. So we've done that. Next, we need to go and do it on all of the interfaces. So we will do interface gig 0/0. And all we need to do there is, oh, lost mouse, IPv6. We need to make sure that we're doing OSPF 1 area 0, interface serial 00. Again, IPv6 OSPF 1 area 0, interface serial 001. All right, so we've done that. Next, we're going to do the same thing except on router 3. So first thing is, let's go ahead and turn on IPv6 routing. Even though it doesn't say to do that, we're going to do it anyway. We're going to set on gigabit 0. We're going to set a link local address, FE83, as it states right there. We will do the appropriate OSFP version 3 requirements. So IPv6 router OSPF1. Got our process ID is 1. Router-ID, we're doing 3.3.3.3. We need to enable it on all of the interfaces. Gig 0 and serial 0. And for those instructions, we are done. Let's go ahead and hop in our router. Let's go ahead and get started. So I'm going to add in a few more commands, enable and config T. Help make this go a little quicker. If you're not getting it to start, let's do show IP. Sorry, show run. So we actually have no IPs on any of the interfaces. Even though we did the OSPF, we declared them. So let's hop back into configuration mode. Interface gig IP add in the appropriate IP addresses. 4.0, no shut. Interface 000, IP add 172.31.4.1, no shut. So all I did was these two interfaces and turn them on. I'm going to hop over to R2. Which, because we're doing OSPF, what I'm going to do is edit this a little bit. I'm going to make sure that all of the appropriate interfaces are in a no shutdown state. Enable config team. I have a feeling I need to go back and actually set up the IP address for all of these. Just to make sure. Let's do a show run. Yep, because no addresses are actually set. Even though we did all of the fun parts, we did not have any of the addresses set. So that's all right. Config T. We'll do interface gig first. IP address 172.31.2.1. Subnet of next will be serial. Oh no, because gig actually has another IP address. So IPv6 add. So now we've added both of those interfaces. Let's hop over to serial 0 IP address. We're adding this address right here. 172.31.4.2. Subnet of 252. Next, we will go to interface serial 001 IPv6 add, because this one only has an IPv6 address. All right, so that should be all of the addressing for router B. Let's verify. Show run. IPv6 address, IPv4 address, IPv6 address. Nothing on gig 1, that's fine. On serial 0, that matches. Serial 01, that matches. So we're good here. Let's hop over to RC. All right, so again, I'm going to modify this just a little bit. Since we're having to hit all of the appropriate interfaces. So what I'm going to do is I'm going to modify this so I can include things such as IPv6 address, no shutdown. For interface serial 000, IPv6 add, and again, no shutdown. Make sure they're matching. Yes, they are. I again want to do enable and config T. And paste my configuration in. Oh, I fat fingered something. I fat fingered the interface gig 00, setting the appropriate link local address. I did IPv-P instead of IPv6. So I've set my link local address up. Let's go ahead. Let's do a show run. Unicast is there. Double check the appropriate addresses and OSPF. All right, they all look good. OSPF1. So everything should be working across the board. All right, so we need to do one last thing, which is to set up the appropriate subnets and addressing on our PCs. So for PC A, the IP address information should be, we're doing the last usable, so that means 172.31.1.254 with a subnet mask of 254.0. Again, it's using the last usable address, and this will be the address of the router, so that should be fine. I'm gonna skip RB for a second. I'm gonna go to RC. Sorry. I just did PCA. I'm gonna skip PCB because I want to do RB last. I want to do PCC. Here we're doing IPv6. We're using the last usable with a /64. And we're using the link local address as its gateway. IPv6 gateway, that guy. I'm not setting a dedicated link local address for it. I'm just using the link local address of the gateway for its exit point. All right, so PCB is going to be one of those weird ones because again, we are looking at both IPv4 and IPv6. So using this information and using these steps here, second assignable, again, read these, that's how I'm getting the numbers. I'm looking at both of these addresses. So first one is IPv4, so 31.2.254. Oh, I fat fingered it. It should be 3.254. Subnet mask should be 255.255.254.0. And wildcard, sorry, not wildcard, gateway should be 31.2.1. Lastly will be the IPv6 address. With a /64. Again, I'm just taking that information right there. And the router is FE80::1. And now we should be able to ping between PC-A and PC-B, and between PC-B and PC-B. Or sorry, A and B, B and C. So let's go ahead and try that. PC-A, we will ping PC-B, ping 172.31.3.254. First packet should fail, that's normal. The rest of them should come, so let's do it one more time. Alright, let's go to PCB. Let's go ahead and try to ping PC-C. Again, the first one should fail, that's normal. If they all time out, we're going to have to check the routing table. So it's very common for these dual stack type routers to actually not converge using OSPF v2 and v3. So sometimes you actually have to re-enter certain commands. Configure terminal. Let's go to interface gig0. So it's common to have to turn off the IPv6 portion. IPv6. Sorry, yeah. No IPv6 OSPF 1 area 0. And then re-put it in. So that's the first thing I want to try, and then I want to try pinging again. If it still doesn't work, then we'll look at more of its config. Alright, so let's look on router B. Do a show run. So I'm just going to go through these steps again. One thing I do notice is we don't have a link local address for gig0. So conf t interface 00 IPv6 address. We will be doing FE81 link local. So that was one of the errors I found. So one of the fun things that I dislike Packet Tracer is sometimes things just don't work. So PCB is not pinging PC-C. And the important thing here is, first of all, recognizing that can PCB even ping the WAN interface of PC-C. Here is the router B. Here is the their address. Here's router C. And again, it's the same group of addresses. 2001 db8:2, 2001 db8:2, : 1: 2. All right, so that does mean that PCB does know about router C's IP address because they are directly connected. It does work. Let's do the same address on PCB. It does not work. The interesting part here is, I'll let it time out. Can we ping the default gateway from PCB, which is FE80::1? Yes, we can. So we are forwarding traffic. Well, you know what? Let's just double check. IPv6 gateway. That is the gateway. Here is our IPv6 address. So we can ping that IP address. So that means we're sending things to the gateway, but router B, which does know about that interface, is not forwarding traffic. So I did this on lab equipment, and I did this in Packet Tracer. This works in lab equipment. This does not work in Packet Tracer. I've done things like clear the IPv6 OSP process, and it did not function. I also did things like just verifying it wasn't a convergence issue. I disabled the IPv6 OSPF 1 area 0, and I re-enabled it, and still did not work in Packet Tracer. In lab equipment, it does work. So I also did the activity results, go through everything was configured correctly except the connectivity test. The connectivity test pinging PCB to PCC is failing. Only in Packet Tracer. In lab equipment, it does work. So scored items, everything is here. Even though the connectivity test is failing, this lab is complete. This is a bug in Packet Tracer. Thank you.